Hello everyone, this is Ashwin here. In this video, we are going to solve the problem K factorization. At the time when Pythagoreanism was prevalent, people were also focused on different ways to factorize a number. In one class, Pythagoras asked his disciples to solve one such problem, reverse factorization. They were given a set of integer, that is a1 to ak, and an integer n. They need to find a way to reach n, starting from 1 and at each step multiplying current value but any element of. But soon they realized that there may be more than one way to reach n. So they decided to find a way in which the number of states are least. All of a sudden, they started on this new problem. People solved it and then started shouting their answer. Crap, there still exists multiple answers. So finally, after much consideration, they settled on the lexicographically smallest series among these solutions, which contains the least number of states. So we have to find the minimum number of factors to reach that n, and also we have to return the lexicographically smallest series. So that is our objective. Here for the example, n equals 12 and a is 2, 3, 4. Using these numbers, we have to arrive at that. Then the following ways exist: 1, 2, 4 and 12. And here we can go from 1, 4, 12 and here 1, 3, 12. So lexicographically smallest is 1, 3, 12. So we will just return that one. If there is no way to reach that element, means we will just print -1. So that's how we are going to solve the problem. Let's see the constraints. So n can go up to 10 to the power of 9 and k is in the range of 20. That is the size of the set A. And this is the range of that set, that is from 2 to 20, and these are all other metrics you can clearly see, and this is the node. I think we already covered these things before itself. Let's see some sample inputs. So here we have to reach 12 and we have 3 elements, 2, 3, 4. So this is already we have seen 1, 3, 12 is the best way to do, and here 15 and 5. There is no way to arrive at 15, so it is -1. And this example we have 72. So for 72, this is one way: 1, 2, 8 and 72. So here they have made an explanation. So here 1 multiplies 2, 2 multiplies 4 and 8 multiplies 9 equals 72. So like that we are going further. And this is the lexicographically smallest one, 1, 2, 8, 72. So I think we can also go in a greedy way, and we are also going to use recursion for this. Now let's dive into the solution. So it's in an easier way. What we are going to do is, from 72, we are going to divide it by few states. So using that, we can able to clearly arrive at the lexicographically smallest result instead of computing all these states. So this is a much easier way. Now let's go into the K factorization function. First, we have to sort all these elements. So that will be a dot sort. So after sorting is done, we have to call that helper function. So result equals helper of n, an empty list that will store the factors and the array elements, that is A. Now let's define the helper function. Helper of element, that is the current element, factors, and this is A. Now again we have to set the base condition. So base condition, that is if element equals 1, then we will add this into the factors dot append 1, and we will return the factors, as this is the end of the factorization. So this is the answer we are returning. So this is the base condition, and for terminating condition we can have if len of A equals 0. That means we don't have any more array elements to do the factorization. Then we will return in a list -1. It means we cannot possibly find the solution. So why I'm returning it in the list means because in the main function it will just concatenate the list into a string. That's why I'm just returning it as a list. So these are the base conditions. Now let's go for the main logic. Main logic. Now if element modulus a of -1 equals 0, what I am doing is from the reverse I'm just taking the modulus. So here in this case if we sort the array means it will look like this. So it's better to go with an example. So 2, 3, 4, 5, 6, 7, 9, 10 and 16. So element will be 72 and the last element we are fetching it from here. So it will just say 72 modulus 16. So the remainder is 8. So it's not possible. 10 is also not possible. 9 is possible. So 72 modulus 9 is 8. So it satisfies the condition. Now when the condition satisfies, we will add that to the factors. Factors dot append element. So we are just appending this 72 currently, and we will just update the element. Element equals element divided by a of -1. So this element will be converted to 8. So that is our next element. So from this we have to minimize it. If the condition not satisfies means we have to try out the next number. So for that each time we will be just popping out the list. So a dot pop. So it will just remove the last element from the array. So far these two will be eliminated. So if these two eliminated means we do have these things. So these are the elements are there, and here the element is 72. Now the element is 8. Now again it will keep on checking for the condition. So all these things will be eliminated. So when it reaches 4, so 8 modulus 4 is 0, it will be entering, and we will be adding this into the factors and updating the element. So element will be updated to 2, and all these things will be eliminated. So I'll just copy this, paste this, and again these things will be eliminated because it's not going to 0, and finally we are arrived at 2, but the element is changed to 1, and we have just 2. So when we have reached 1, it will just check whether the element is 1, and we will just add that 1 to the factors and return it. So far we have added 72, 8, 2, and lastly we will be just adding this 1. So all will be stored in the result, and before that we will be returning helper of element comma factors comma a, and finally this result will be stored here, and after that we will return result of -1. So currently I am just reversing the result. So reverse the result. So why I am reversing it is, so currently it will store like this: factors equals 72, 8, 2 and 1. While returning it, I'm just reversing this factors. So that's why I'm just reversing it here. You can also use reverse function if you want. And here remove last element, and all the things remains the same. This is the whole logic of this problem. I think using this tracing itself, you can clearly understand how the whole thing is going. Let's run the code once to check whether it is working or not. So it is working fine. Let's submit the code. As you can able to see, all the test case has been passed, and this is the whole logic of this problem. And again, try to trace this problem with this examples, so it will be very helpful for you guys. And that's the whole logic. If you have any other logic other than this, please leave a comment below. Stay tuned for the next video.